Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
Logarithm is just like indices. Just like we have laws of indices, we also have laws of logarithm. Can you remind me, if we have for indices, please, you may need to zoom in to at least 200% to see this thing better at your end. If you have ax times a raised to the power x times a raised to the power y, what does it give in indices? A raised to the power x plus y, isn't it? That will give a raised to the power x plus y. You see, this is similar to that. Log of a base a x times y will be equal to log of that base x plus log of that same base y. By the way, you need to even understand what this thing is about. Of course, you said it will be equal to a raised to the power x plus y. Am I right? You say it's equal to a raised to the power x plus y, right? And you know about this one too. Log of a raised to the power x divided by log of sorry, let me not use log yet. Let me write it in indices. A raised to the power x divided by a raised to the power y. You say this will be the same thing as a raised to the power x minus y. You will see that it's related to this division law. X divided by y will be equal to log of x minus log of y. I hope you can still hear me. Okay, always respond and be more audible. All right, first of all, I need to explain to you what logarithm is about. Let me explain what logarithm is about. If you have a raised to the power, or let me use numbers, 10 raised to the power 3. What's 10 raised to the power 3, for instance? Say that again. 1000. Now this is indices form. This same thing I've written in indices form can be written in logarithm form. In fact, indices and logarithm are just two ways of writing numbers that have to do with powers. So I've written it in indices form. I'm going to write it in logarithm form. This is log form or logarithm in full. Logarithm. This is the way it can be written in logarithm. So we say log of 1000 in base 10 is equal to 3. Let me show you. This one that is the base for the indices is written here for the logarithm. The answer is written here for logarithm. The answer for indices is written here for logarithm. The power or the index is written here. So you can change indices to logarithm. You can also change logarithm back to indices. Stay on the Jamboard, please. Always stay on the Jamboard. I hope you can hear me. You can change indices to logarithm. You can always stay. You can also change logarithm to indices. Is your Jamboard opening? All right. Good. Yes. Okay, you didn't know exactly where I was. Can I say what I said again? I'm on page 18 of 20. So I said, in indices form, you have 10 raised to the power 3 equal to 1000. In logarithm form, I can just say log of base 10. This 10 now stays at the base. Log of 1000 in base 10. Log of 1000 in base 10 gives 3. So I can change indices to logarithm. I can also change the logarithm back to indices. Let me give you one to see if you can write it following this method. Let me write another one. In indices, if I say 2 raised to the power 3, or let me say 2 raised to the power 4 is equal to 16. How can I write this thing in logarithm form? Let's go.
Log.
Good. Let's go log. Log 16. Log 16 in base what? 2. Because the number that's the base is written there. We give you what? 4. Okay. Let me try and change logarithm to indices. I've changed indices to logarithm. Let's try and change logarithm to indices. Let me write log 81 in base 3 equals 4. Change it to indices. What will it be? I'm listening. I'm listening. Change it to indices.
3 raised to the power 4 equals.
I like that. 3 raised to the power 4 is equal to 81. And if you check 3 raised to the power 4 will give you 81. 3 times 3 times 3 times 3 will give you 81. So logarithm is just another way of expressing some indices. And that's why their laws are related. Okay? So let's go back to the laws of, okay, let me write it as a general rule. So if I have, the general rule is a raised to the power x, if a raised to the power x gives y, write it in logarithm. This is in indices. Okay, let me write it in logarithm. Go say that again. Log y in base a is equal to x. This is in logarithm form. So that's a general rule. Let me put it in a box. Take note of that. The indices and the logarithm. So they are basically saying the same thing. So their laws are related. You know, logarithm for the red one, indices for the yellow one. All right, so back to the laws. Go back to the left-hand side. Scroll to the left-hand side again. Are you seeing it clearly? This left-hand side. A raised to the power x times a raised to the power y in indices gives a raised to the power x plus y in indices. Similarly, in logarithm, please, can you be audible? Say that again. Be audible. Read out the equivalent law in logarithm. I need it to be more audible.
xy plus a. Log xy base a equals to log x base a plus log y base a.
Beautiful. Log of xy in base a is equal to log x in base a plus log y in base a. You can also say log, another way to say it is, you can also put it this way. Log of x in base a plus log of y in base a is equal to log xy. You know, it's the same thing. If the left hand side gives the right, if the left hand side gives the right hand side, the right hand side will also give the left hand side, isn't it? Now the division law, if you have one dividing the other, you just separate them and subtract. So it becomes log of x in base a minus log of y in base a. If you have log x over y all in base a, it will give you log of x in base a minus log of y in base a. That's the division law. Then the power law. Are you listening?
Yeah.
If you have log of x in base a raised to power m, simply bring down the m. It becomes m log of x in base a. I'll give you examples. I said if you have log of x in base a raised to power m, you simply bring down the m. It becomes m log of x in base a. An example is this. Okay, before I take that example, look at this one. Read out what I just circled.
1 over x.
Do you know 1 over x is the same thing as saying, let me zoom it to 200% so I'll tell you what it is. One of, so that you, pardon?
1 over x is minus x.
Say that again.
1 over x is minus x.
See, 1 over x is the same thing as saying, this is another way to write it, log x raised to the power minus 1. Because 1 over x is the same thing as x raised to the power minus 1, isn't it? In indices, 1 over something is that thing raised to the power minus 1. Do you know?
Yes.
Apply this law. Apply the power law. Wouldn't it give you, all you need to do is take the minus 1 down, is it not?
Yes.
It becomes minus 1, then log in base a x, which is what we have here. I think that's clear. Or simply minus log x in base a. Now there's another special law I just want to introduce to you. We've talked about 4 laws already. Actually 3. This last one is just an extension of power law. But let me talk about this special law. All of them can be derived from each other. Log of a in base b is equal to 1 over log of b in base a. In fact, I want to explain something first. Log of a in base b is equal to 1 over log of b in base a. I need to introduce yet another one. I have to write it in black. We'll be applying all this. I'm just trying to squeeze all of them inside here. I want to introduce this one. Log of, let me clean this a little bit. Log of what? Log, oh, okay. I'm coming. I hope you're still here.
Yeah.
Okay. Log of a in base b is the same thing as saying log of a over log of b, so that you can see why it gives that in any given base. Oh, I should have introduced one before this one. I can write it at the top. Let me see. You will see this one. I said log of a, log of a in base b is the same thing as log of a over log of b in any given base. Let me just call that base x. Any given base x. All of them, any base. Just use a common base for both of them. Read out what I just wrote now. Is read it out again. Is you need to read it fully, please. Log of a in base b is equal to log of a over log of b, all in any given similar base. S can be any number, any positive number. I think you need an example right away so that this one will be clearer. You need to have an example right away. Let me give you an example right away. Let me give an example right away for this one. Are you ready for that? Okay. Log of eight in base 2 is the same thing as, apply that rule. Let me show you. Apply that rule here. Apply the rule and tell me what it will be. Log of 8 in base 2. Apply this rule here. Oh, I like that. It's equal to log of 8 in base anything over log of 2 in base that same thing. What base do you want to use now? Let's even use 2. I said any number can be used, so let's use the same number 2 because I want to use it to explain something to you. Log of 8 in base 2 is the same thing as log of 8 in base 2 over log of 2 in base 2. Having said this, I want to just show you something. There's another law. Log of, there are many laws, so log of a in base a is equal to 1. Did you see what I just wrote in blue? It's equal to 1. Log of any number in the same base is equal to 1. That's what I mean. Can you change this thing to indices and see if that law will make sense? Change this thing to indices. Change what I wrote in blue. Change it to indices form. Are you sure it's supposed to be 1?
No. A raised to power 1 equals A.
Good. A raised to power 1 equals A. Is it not correct? Yes, of course. A raised to power 1 will give you A every time. A raised to power 1 obviously always gives A. So that it makes sense that log of any number in the same base is equal to 1. Let me write this last one below it. I have to use yellow. What color can I use? Maybe green. Log of any number. Okay, let me see. If you change this one to indices, you will know. Log of 1. Sorry. Log of 1 in any base. What do you think it will give you? Change it to indices, you will get the answer yourself. Log of
and
what?
a raised
Log of 1 in any base. Sorry, log of 1 in any base. For instance, a. What do you think it will give you? Try to change this thing to indices. You will see what the answer will be. A raised to power what will give 1? Good.
zero.
Oh, sorry, I didn't know you were saying it. That's fantastic. A raised to power 0. A raised to power 0. Interesting. So because a raised to power 0 is equal to 1. Do we agree? So take note of these additional two laws I wrote in green and blue. And their indices form to prove it. Alright, if that is the case, look at this. You will see how this one will simplify. I was trying to write something here. I'm back to it again. Let me see where I was writing it. This one, you will be able to use it to actually show that this is correct. You can use it to show that this is correct. Can you see what I circled?
Can use what to show?
Have you seen what I circled?
Yes.
Okay. This is how we can show that. We can actually say that this is the same thing as log of... No, that space is too small. That space will not be enough for it. So let me write it down here. Log of a in base b. Let me write it down here. Log of a in base b. Hold on, let me write it down here. That space is too small. Log of a in base b. Please scroll down towards the right so that you can see where I'm writing it. Yes. Log of a in base b is equal to, based on our rule, it is the same thing as saying log of a over log of b, all in the same base. We can decide to choose the same base as a and a. Right? What is log of a in base a?
Log of a is a.
What's log of a in base a? Don't worry, 1, of course. Log of anything in the same base is 1. You're right. Log of a in base a is 1. You're definitely going to listen to this thing again. Log of a in base a is 1. Okay. So this whole place becomes 1. This whole thing becomes 1. So this becomes 1. The whole numerator becomes 1 over the denominator. Log of b in base a. I just used that to prove what I wrote earlier at the top right corner, top left corner. This rule. Okay, please let's attempt some questions. Let's attempt some questions. Please make sure you zoom this thing to about 200% because I will just attempt a few. Okay? Go towards the right. Towards the right away you have the questions. Right? No, left. Sorry, I mean left. Left. Okay. For instance, it says log of 10 or log of 100,000 in base 10. Log of 100,000 in base 10. Are you ready for that?
Yeah.
Let me be solving it in blue. In that same space. Log of 100,000 in base 10 is like saying log of in base 10. 100,000 is same thing as 10 raised to the power 5, isn't it?
Yeah.
100,000 is the same thing as 10 raised to the power 5. 10 raised to the power 5. And this is the same thing as apply the power law. You can take 5 down now, is it not?
Yeah.
It becomes 5 log 10 in base 10. What is log 10 in base 10? Sorry. No, log 10 in base 10. Log of a number in the same base. 1. So the final answer will now be what? 5 times 1, which is 5. So the answer is 5. Now see the way I did it. The question is, I hope you can see it though. It looks like you have to, okay, I think you're seeing it. Log of 100,000 in base 10. And I said this 100,000, change it to 10 raised to power 5. So it becomes log of 10 raised to power 5 in base 10. Apply power law. See the power law. Power law is anything, if you have log of anything raised to power anything, take the power down. It becomes m. For instance, log of x raised to power m in base a becomes m brought down, then log of x in base a. That's what I applied here. That's what I applied here. So log of 10 raised to power 5 in base 10, I brought 5 down. It becomes log of 10 in base 10. 5 log of 10 in base 10. And log of a number in the same base is 1. So it becomes 5 times 1, which is 5. If you understood it, let me know so that I can move on to the next. Are you ready?
I understand.
Okay, can we do this one? This one here. 0.001 is the same thing as 10 raised to the power minus 3. Am I right?
Yeah.
So this is the same thing as, let me write it in green. Log in base 10, then 10 raised to the power minus 3. So what should be the answer? Minus 3 log in base 10, 10, which is simply minus 3. The answer is minus 3. Do you agree? Okay. Let me allow you to solve this one. Hold on, let me see. Let me see this one. The way to solve it, you have to apply. Please, let me write this one down. Let me write this one out. I'm coming. Log in base 10, 100, then root 10. That will be 100 times root 10, which is that minus that. Okay. Let me write it out. We need enough space. Log in base 10, 100 root 10. I need to help you to solve that one. I'll give you one that you solve. Let me write it below. Log in base 10, 100 root 10. Do you know it's the same thing as saying log in base 10, 100 times root 10? I hope you know. I hope you know.
Yeah.
Okay, let's apply the multiplication law. Check out the multiplication law. I know you have to be scrolling up and down because of the way we zoom this thing in. Multiplication law. When you have log of something times something, you simply say log of one of them plus log of the other, isn't it? You've seen it. So let's apply it there. Let's apply it there. Let's apply it there. So this thing becomes log in base 10, 100 plus log in the same base 10 root 10. Did you see that?
Yeah.
It makes sense. So simplify them one after the other. Simplify them one after the other. Let's simplify this one. This one will be log in base 10, 10 raised to the power 2. That's 400. Is it not?
Yes.
Why this one will be log in base 10, 10 raised to the power half. Is it not? Because square root means raised to the power half, isn't it?
Yeah.
Okay, let's apply power law. 2 will come down, half will also come down. So this gives us 2 log in base 10 in base 10 plus half log 10 in base 10. So
Okay.
what will be the final thing? 2 times the whole of this is 1. Log in base 10 in base 10. Log 10 in base 10 is 1. Log 10 in base 10 is 1.
Times 1 plus half times 1.
Exactly. So which is 2 plus 1. Oh, sorry, 2 plus half. Yeah. Simply 2 plus half. Or 2 and a half.
Also 2.5.
Or 2 and a half. Yes. You see how these things can be
Yeah.
really interesting. You're going to do a lot based on all these things I explained to you. You're really going to do a lot, and I'll just be watching you do them. All of these, you'll just be applying the laws one after the other. Some of them you have to solve an equation. Go towards the left hand side. Let me see if you can see what I'm circling.
Yeah.
If you have, sometimes you may need to change them to indices. You can get it by changing them to indices. You'll be able to get it. For instance, change this one to indices. Change what I just circled here to this G to indices. I think it will be 2 raised to the power 4 is equal to what?
X minus 1.
X minus 1. And what is 2 raised to the power 4? That's 16.
And
16 is equal to x minus 1. So what's x? X should be 17 now, is it not? If you solve it, so x is 17. You know, you can apply some of these to solve all these ones. I know these ones you'll be able to, you should be able to do this one. This one is like saying log in base 3, 3 raised to the power 4. The one below it, 3 raised to the power 4. Because 81 is 3 raised to the power 4, which will give you 4 log 3 in base 3. And the answer will now be 4. I'm just giving you a clue because you're going to do many of them. So this one you're giving log in base 3 or log x in base 3 plus 2x minus 5 in base 3 equals 1. So I think what you did, you made a mistake here. I will explain something to you. You made a mistake here. I will explain it to you. First of all, what you did was you applied multiplication rule. Log x times, or rather log x times 2x minus 5, all in base 3, right?
yes.
Okay, that's correct, because they are all in the same base. So you simply said x times this, all in base 3, and x times this gives you 2x squared minus 5x, right?
Yeah.
Equals 1. All right. Now, the only thing I need you to correct is you cannot just bring this one across like that. You can't just bring the 1 across because it has to also be in logarithm and in the same base. In fact, once you can put it in the same base, you can now solve it. So put 1, rewrite 1 so that it will be logarithm in base 3. Logarithm in base 3. So this step is okay. Let me not erase it completely. Let me just leave it to this point. Yeah. Rewrite 1 so that it will be logarithm in base 3. So yeah, once they are both sides are in the same base, you can now solve. I see what you're doing. Oh, sorry. Tell me what you want to write. Tell me what you want to write. Let me write it.
Well,
Go ahead, I'm listening. You want to rewrite 1 so that it will
log,
be,
log, 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 log,
yeah, I've written it log what?
um,
You're just trying to rewrite 1 so that it will be the same thing as log in base 3. I think what you're trying to say is log 3 in base 3, is it not? Because log 3 in
yeah,
base 3 is the same thing as 1.
yeah,
See, anytime you have 1, just write log of that base in the same base.
okay,
If it is 0, you would have written log 1 in that base. You know, log 1 in base 3 is 0, is it not?
yes,
Then if it is 1, you will just write log of that base in the same base, log 3 in base 3. Now, once both of them are in the same base, you can cross out the log. At this point, you can cross out the log. The log can cross out. Just like log divided by log, yes. The log can cross out. So you just have 2x squared minus 5x equal to 3. Good. Please, let me just be telling me what to do. Let me finish it up here so that we can work faster since I'm writing with a stylus. Okay, I think you can.
yes,
2x
x
squared.
squared minus
5.
5
Okay, 2x squared minus 5x. Go ahead.
minus
Minus 3
2
now equals 0. Beautiful. You are a very strong math student. Yeah, don't worry. Just undo. I've written it. Just undo. I've written the 0. Okay. Yeah. So now, the factors are. You know how to factorize, do you?
yeah,
You're trying to remember. You know, normally you will do 2 times 3, which is 6, or minus 6. What are the factors of minus 6? That will give
that's all,
you, when you add, you will get minus 5. When you multiply, you get minus 6. That will be
plus
plus 6, plus 6, and no, minus 6 and plus 1. It will be minus 6 and plus 1, or plus x. When you multiply them, you will get minus 6. When you add them, you will get plus minus 5. Let me remind you the fact. Okay, so you just factorize in pairs. Good, you know this. No, from here. Okay, it's fine, the way you're doing it is fine. All right, so go ahead and factorize in pairs.
okay,
I'm so proud of you. All right. Yeah, close the bracket. Plus what? Excellent. Plus 1. Open the bracket. X minus 3. Beautiful, 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 beautiful. Okay, please let me just finish it up so that we can work faster. You know what to do. Equals 0, yeah. So you know 2x plus 1. Okay, go ahead and write since you are writing already. Go ahead and write. Exactly. So you pick or. Interesting. See this thing, you are a very strong math student. You will cope with all this. You just need to be exposed to them. You are a very strong math student. All right. So x is equal to, that's minus 1 over 2. Just write minus 1 over 2 so that we don't waste time. Yeah, minus 1 over 2, or x equal to or x equal to my positive 3. So these are the answer. All right, let's pick that one from that past question. Let's go back to it. So that's on page 1, page 18 rather. No, page what again? Page 1. Okay, let's go there. Okay, page 1. Yeah, there's a space below that I can solve it. You will just be telling me what to do. I have to give you a little hint. That's question number 7. Let me zoom it to 200 so it can come out better at my end. Question number 7, it reads log in base 2. No, that's square root of 2. Log in base square root of 2. Wow, this question is really crazy. They really made it hard. I'm just saying that it's square root of 2. Log in base square root of 2. That's root 2 there. Sorry. Let me go back there again. Sorry, I mistakenly left there. Okay, let me zoom in. Need to zoom in very well so I will be able to see it. Okay, so log in base square root of 2. Log of 4 in base square root of 2 plus log of 16 in base half. Then log of 32 in base 4. Okay, please, I will try and squeeze out the answer by the right hand side, left hand side, so I don't have to leave that space. See, I told you when you have that, there's a way. Remember there's a rule I gave you. If you have log a in base b, it's the same thing as writing log a over log b all in base a, or all in the same base if you like. It could be base a, or base b, base b. Did you see what I just wrote?
Yes.
Okay, I gave you this rule. So we can apply this rule here. We can apply this rule. For this log 4 root 2, I can write it as this. Let me split all of them. That's why I said I need to give you some hint here. Log of this 4 root 2 is the same thing as writing log 4 all over log 2. Will it even help? Log root 2. No, will it help? Yes, it can help. All in the same root. Let me see if it can help. No, it won't help. There's no need. We do it differently. It won't help. Even though it can achieve something, but there's no need. Let me use a different method. What did you say? Like if you have log 2 in all over log 3. Are you saying can log cancel out log?
Yeah.
No, it doesn't. No, it can't. No, it can't. It's just like you cannot say sine 30 over sine 20. Can you just cancel out sine? For sine 30 over sine 20, can you just cancel out sine?
No.
No, you can't cancel out sine. Sine 30 is together, sine 20 is together, so you can't cancel out sine and sine. The same way you can't cancel out log and log. I'm happy that you asked that question. You cannot cancel out log and log.
But even if the days are the same.
Even if you think they are the same. The only time that happens when you can cross out is like the one I gave you. If you have something like this, let me write it out one more time. If you have, for instance, log x in base 2 is equal to log 8 in base 2. Now, this one, read out what I wrote in blue now. Read out what I wrote in blue. Log x in base 2 is equal to log 8 in base 2. In this case, you can cross out log. You can cross out log. This one is valid. So x is equal to 8. Is that understood?
Yeah.
But where you have that, you can't just cross out log like that. Okay, I think I can erase it and then. So what I'm saying is there should be a different way of doing this. So log A in base B is equal to 1 over log B in base A. Apply it to this one, log 4 root 2. Log 4 in base root 2. Let's apply it log 4 in base root 2. What will it be?
Equals to 1
What?
over log 2 in log root 2 base 4.
Good, log root 2 in base 4. So that's why you will apply log root 2 in base 4. Log root 2 in base 4, and it should be easy for you to do now. Log root 2 in base 4. Are you ready?
Yes.
Okay, this is the same thing as saying 1 over log in base 4. Root 2 is 2 raised to the power half, right?
Yes.
2 raised to the power half. Did you see that? So this is equal to, we're just simplifying 1 over log in
Yes.
base 4, then 2, or rather half 2 root 2. Sorry, you know the half will come down. You know that the half will come before the log. Half will come before the log. So you have half log in base, half log 2 in base 4. Did you hear me?
Yes, I heard you.
Beautiful. Half log 2 in base 4. There are many ways to do it. You can convert this to indices. It will help you to find what this will give. But there are actually many ways I can help you to do this. Convert this to indices. You can just...
Hello?
I'm here. Can you hear me?
Yeah.
I was asking you to convert this one, only this one I circled in yellow, to indices. That's one method to do it. It will be easier for you. Just this one I wrote in yellow, call it x equal to x and change it to indices. Changing it to indices will be 4 raised to the power x equal to 2. So what should x be?
4 raised to power half.
4 raised to the power half will give you 2. Is it not?
Yes.
So the whole of what I circled in yellow is equal to half, right?
Yes.
X is equal to half. The reason is when you change this thing to indices, you're getting, I can see it so that when you are reading it, you will understand what I did. This is like saying change to indices will be 4 raised to the power x equals 2. So x has to be half. So the whole of what I wrote in yellow is half. And so this thing simply becomes equals 1 over half times half. Do you understand?
Yes.
What is half times half?
1/4.
So 1 over 1 over 4. 1 over 1 over 4. What is 1 over 1 over 4? It actually gives 4.
Yes.
1 over 1 over 4 gives 4. I just simplified the first.
Yes.
I have simplified the first one. Simplify the second one too. Log half in base 16. Or sorry, log 16 in base half. Let's do that very quickly so that we can. Log 16 in base half. Let me write it down in a different color. Log 16 in base half. Let's apply that rule again. What will it become?
1 over log
Half in base 16. Good. And half, this gives what? That's 1 over log 16, log 2 raised to the power minus 1 in base 16. Do you know?
Yes.
half is 2 raised to the power minus 1, isn't it?
Yes.
So this is 1 over log half in base 16 is the same thing as 1 over log 2 raised to the power minus 1 in base 16. Take the minus 1 to the other side. That's take the minus 1 to appear before the log. That's power rule. That will give us minus 1 over log 2 in base 16. Am I right?
Yes. Yes.
Okay, so finally, what do? Apply that same rule I just gave you. You can, let's circle this whole place in red. This whole place in red. Oh, sorry, this thing is mutilated. I think I should leave it. This whole, the denominator, the whole of the denominator is the same thing as, if I call it x, what should x be? 16 raised to the power what will give you 2? That would be 1/4. 16 raised to the power 1 over 4 will give you 2. Will give you 2. Do you know? 16 raised to the power 1 over 4 will give you 2. Oh, hold on, let me see. Let me be sure. No, let me be sure.
Okay.
What does it give?
3 raised to 1 over 4 equals to 2.
Equals to 2. Yes. You're right. You verified that.
Yes.
So x is equal to 1 over 4. So we are replacing the whole of this one under with 1 over 4. And so please, I need to write it at the top here. Everything will now become, alright, can I just say x is equal to, therefore x is equal to 1 over 4. Oh, sorry, 16 raised to the power 1 over 4 will give, yeah, x is equal to 1 over 4. 16 raised to the power 1 over 4 will give 2. Changing it to indices, 16 raised to the power 1 over 4 will give 2. So x is 1 over 4. So the whole of this is 1 over 4. So let me now rewrite it. You're going to have this. This is a very exciting one. So you have 1 over minus 1 times 1 over 4.
Yeah.
So what will it give us?
Minus 1 over 4.
1 divided by minus 1 over 4. So what will it give? Minus 4. This will give minus 4. Do you know?
Yes.
Okay. This gives minus 4. Okay, so we've simplified the other one, this one to get minus 4. That's we've simplified log of 16 in base half to get minus 4. So the last one you should simplify is log of 32 in base 4. This one should be easier. Log of 32 in base 4.
Yeah.
Log of 32 in base 4. Where do we have that? Let me do it here, so that you can now add up everything. Log of 32 in base 4. This one you can easily use the same log. I can express it like this, equal to log of 32 over log of 4, all in the same base 2. Do you understand?
Yeah.
In the same base 2. Why am I doing it in the same base? So I can raise it to power 2. Watch it, see why I'm doing that. This is the same thing as, right?
Why is this?
Any base can work. Remember the rule. Remember the rule is log of something in a base is equal to log of that thing over log of the other in any base, but that must be the same. Do you need me to remind you of that rule? You remember now? Or should I remind you? Okay. Alright, so this is simply log of 2 raised to the power 32 is 2 raised to the power 5 in base 2 all over log of 4 is 2 raised to the power 2 in base 2. Do you know 32 is 2 raised to the power 5? 2 times 2 times 2 times 2, okay. So this one is simply 5 log 2 in base 2 all over 2 log 2 in base 2. And so that one will simply be 5 over 2. This one is 5 over 2. Because log 2 in base 2 is 1. Log 2 in base 2 is 1. So that this one is 5 over 2. So we've gotten all of them. Let me just circle all of them in yellow. This is this. This is this. And the other one is this. So we have 1 over... Abby? No. Where did we get the first one? Sorry. The first one is 4. Okay, the first one is 4. So let me write it in yellow and circle it. Okay. 4 minus what? 4 and then plus
minus 4 minus 5 over 2.
Excellent. Excellent. So this one will be 4. This one is minus 4. This one is minus 5 over 2. So we now know the answer. Am I right?
Yes.
Which letter is the answer? This first one is 4. This one is plus minus 4. This one is minus 5 over 2. So the option is A, which eventually give minus 5 over 2. Yeah. The option is A. Alright, I think you will need to practice more. If you are given log 2 equal to this, log 3 equal to this, they would have provided these values, right? And then they ask you find maybe A. They give you find log 6, of course all in base 10. How will you do that? Do you know log 6 is simply log 2 times 3? Is it not? Did you see what I wrote?
Yeah.
Log 6 is simply log 2 times 3, which if you apply the law of logarithm will be log 2 in base 10 plus log 3 in base 10. Is it not?
Yeah.
And you have their values. What are their values?
0.3010
So,
plus 0.4071.
plus 0.40071. So in case you see a question like this, it's not a big deal. You can just resolve it. Then let me just make it a little bit tougher before I let you go. If you are given something like this, find log, what can I say, 50 is 25 times 2, or 5 raised to the power 2. 50 is 25 times 2. Can I give 75? Okay, find log 75. Log 0.75. Let me even write. Find log 0.75. Do you know 0.75 is the same thing as saying log 75 over 100, right? 75 itself is what? 25 times 3, am I right? 25 times 3 be 4 over 100. Did you see what I wrote?
Yes.
Good. 25 times 3 over 100. And 25 itself is what? This is where it gets interesting. 25 itself is 5 raised to the power 2, isn't it?
Yes.
25 itself is log, let me just write it all in a straight line. Log 5 raised to the power 2 times 3 before over 100. By the way, 100 itself is 10 raised to the power 2. You know. Let me see if there's any need to put that 100. Okay, let me leave it. Yeah, it's 10 raised to the power 2. So from here, you should be able to simplify it. Can you? Do you know what to do? This is saying apply the rule. For multiplication you add now, is it not?
Yeah.
For division you subtract. Remember, all of them are all in base 10. In base 10, in base 10, in base 10, in base 10. They're all in base 10. All these are in base 10. For multiplication you add. For division you subtract. So I would have simply said log 5 raised to the power 2 in base 10 plus log 3 in base 10 minus, oh sorry, that is, I need to write it in smaller characters so I can take everything. Log 5 raised to the power 2 in base 10 plus log 3 in base 10 minus log 10 raised to the power 2 in base 10, is it not?
Yeah.
I hope you understood what I did. This time this
Yeah.
you do plus, division you do minus. So that's it. I just don't want you to see this and think it is anything serious. You know, 2 will come down, isn't it?
Yeah.
So you have 2 log 5 in base 10 plus 3 log, sorry, no, it's not 3, you just state the way it is, log 3 in base 10 minus 2 log 10 in base 10. That's all. And you know what log 5 in base 10 is? We are giving log 5 in base 10 to be what? 0.689. So that you just have 2 times 0.689, 6989 plus log 3 is 0.477, 4771 minus log 10 in base 10 is what? 1. So 2 times 1 is just minus 2. So you simplify and then you get your answer. I think that's cool.
Yes.
Beautiful. Okay. Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to 2 main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.